Yes, sir.
Okay, so going to start this, I have taken a new laptop to show all the things. So as I told, we'll start with keel.com. That is the software we're going to use. I think we'll go to downloads, product downloads. So you'll go to C51. Okay, before going to that, I just wanted to tell you what all things we are going to use. Please mute your mic, someone. Rinku, please mute your mic.
Yes, sir.
Okay. So to whatever language we are using embedded C for this particular topic, embedded C, and the software on the platform we are going to use Keel, basically Keel software. So basically this is the platform where we'll get the compiler, we'll execute the program, and finally we are going to upload that program. Okay, so that is the two. And for simulations, okay, so then for software perspective side, we're using two softwares. One is what is the again the platform or IDE, you can see. So platform IDE, Keel IDE basically. This is called Keel IDE, and software where you using Keel. And for simulation, we are using Proteus. And Keel software mainly, this is the editor. Okay, there are two softwares we are using. And apart from this, okay, first it's a quick 1 minute. So you can give anything, you can give, I'm giving anything, so it's fine. So if you'll do submit, what it is telling, job title, submit. Once you'll submit, you will get this link. Okay, once you'll submit, you will get this link. This from here, you are going to download the software. So it's a very small software. It's like 105 MB. So now once it is download, then I'll try to install the software. One more software, as I told, Proteus. That also I have downloaded. If you want, I can share with you. So both the softwares now downloaded. Now I'm going to install that one. It will take also very less time. So this is the Proteus software where we are going to do the simulations. Please guys, who all are not telling anything, not asking anything, please mute your mic. So what microcontroller we are going to use? So before going to that, I'll just use one basic microcontroller, that is 8051. The controller name is 8051, and the microcontroller name is AT89C51. If I'll describe everything, I cannot finish in 1 hour. So I'm just giving you the short things. What is microcontroller? Anybody have any idea what is microcontroller, guys? Now you can unmute and you can speak. What is microcontroller? Anyone? You can unmute them so that they can speak something.
Sir, are you hear me, sir?
Yes, you can.
It's peripheral chip inside. I think exactly not correct. Inside the
Okay.
peripheral chip and memory.
Okay, fine. So basically microcontroller means what is that? So it's a device, right? It's a device. So I can say it's a device. And what all things are present? What all things are present? First thing, see, if you have done with your things, you can mute yourself. If you're not telling anything, you can mute yourself. You are Madhul Gupta. If you have done with yourself, you can mute. Madhul Gupta, are you there? Aditya, if you will speak like this, then I'll tell to them to unmute everyone. Mute everyone. Sorry. Okay. Now, so what is microcontroller? So first thing, microcontroller is there is one CPU. There is one CPU. Okay. Like it's a 8-bit CPU or 16-bit CPU or 32-bit CPU. It have some memory. In terms of memory means it have RAM, it have ROM, it have flash ROM, all these things there. Apart from this, if I talk about peripherals, it have some ports, it have some GPIO will be there, general purpose input output pins will be there. Then apart from this, if you'll see, there are some modules like ADC, timer, counter, interrupt, your communication module, serial communication module. Again, in serial communication, it's coming like UART, I2C, SPI. All these things are coming in the serial communication module, UART, I2C, SPI, all these things. So there are so many things are present in the controller. So basically, what is microcontroller? I can say it's a device or it's a chip. I can say it's a chip which will store the program, and execute that program. How it will execute? It will execute that program by using all these things. It will store the program in the memory. It will store the program in the memory and it will execute that program by using all these features. It will execute that program by using all the features. So there are so many microcontroller series families are there. So if we'll talk about microcontroller family, what all things are there? Your AVR will be there. Your 8051 will be there. Your ARM will be there. Your PIC will be there. So there are so many series will be there. There are so many controllers are there. But 8051 is a very basic one. All these are like very advanced one. So again, in each family, there are some controllers. So how you are using iPhone 12, 13, 14, 15, same way. Each family have some controllers will be there. Atmega 8, Atmega 16, like this. So 8051 also there are how Samsung S22, S30, whatever series are there. Same way it will also have different series. 889C51, then C52, like this. Then ARM also like ARM7, ARM9, like this. There are some controllers are there. Like this, so many controllers are there. So our topic is very short time, 8051, and controller name is Atmega. Sorry, controller name is 8089C51. This is the topic. Okay, this is the topic. Okay, so this is the topic. So if I'll go to internet. I'll just search AT89C51. Okay, then I'll go to image. If you'll see the image here, so this is my controller. The controller is look like this ones. Basically, the controller, if you'll see, this is a controller. You can see the controller. It will looking like this ones. It will be, see, you can see this ones. And if you'll see this controller, I want a good image. Okay, if you see this controller, see there is a notch. You can see there is a notch here, notch present. Okay, and from here you will start counting 1, 2, 3, 4, 5. It will count again. Suppose this is 20, then 21, 22, 23, and it will end with how many pins are there. So our controller is this one. So this is our controller. So this is our controller. So my controller is this one. Okay, Atmega. Sorry, AT89C51. Basically, both are same, AT89C51 or C52. This is our controller. So now this is our controller. Everybody able to see? Still, this image is very bad image. I don't want to use this image. I'll take one more image. Okay, good. 88951 and 52 both are same. You can use anything. So if you'll see how many pins are there total here, how many pins you are seeing? So you are seeing total 40 pins. So if you'll see, this is the controller. Controller name is AT89C51. How many pins are there? Total 40 pins IC will be there. Total there are 40 pins. If you'll see in 40 pins, how many ports are present? Ports means you can see here. So this is your port 0. This is your port 1. This is your port 2. And this is your port 3. So there are total port 0. Again port 1. Again port 2. Again port 3. There are 4 ports are there. If you will see each port having 8 pins. It's like a 8-bit controller. So all the registers are like 8 bits. So 8 bits, 8 pins. So here P0, you can say 8-bit register. And how many pins are there? Total 8 pins are there. Total 8 pins are there. Same way also port 1, 8 pin is there. Then same way also port 2, 8 pins are there. Then same way also port 3, 8 pins are there. Total how many pins then? Here, how many pins? Port 0, port 1, port 2, port 3. How many pins are there? So total 32 pins are there. Basically all the 889, S51 and C51 almost all are same. Okay, you can S51 and C51 almost both are same. Pin configuration, register, everything is same. Okay. So now if you'll see here, total 32 pins are there. Total out of 40 pins, there are 32 pins are there. Okay, there are 32 pins are there. If you'll talk about these 32 pins, now, so all the pins you can use as output or input. All the pins you can use as either output or input. What is output or input? That suppose you want to connect some input devices. Can you tell some input devices name? Can anybody tell some input devices name? You can say mouse, keyboard. That means switch. Switch is one input. Okay. Same way you can say your sensor. Sensor also one input. Like this. There are so many. RFID tag. So many are there. Okay. Same way, can you tell some output device name? Output device name. You can say LED light, you can say LCD, you can say motor. All these are coming under output devices. There are again so many output devices are there. So our job is today, you will write the programming, you will write one program for output device and you will write one program for input device. Okay, and how it is working, and you will write from scratch. You are not going to use any header files, or you are not going to use any drivers. Basically you have to whatever in 80 hyphen whatever you are going to write, we are not going to use any outside driver. So that is our main intention. So basically we will write the code from scratch. Okay, so now all these things are there. So now we have to write the program. We have to do the program. So how we will do program? So first program, what you will do? So everybody clear up to this? This 32 pins you can use for input or output. Wherever you want, you can connect. Wherever you want, you can connect. I hope everybody clear. So wherever you want, you can use this one. Okay, so now what you will do, you will start writing program. So first we will do what? Project number 1. So we will do one project number 1 where you will do interface with output device. Interface with output device. Okay, so I can just take one output device, that is LED on. You can take on any output device. You can just consider one LED. You can just consider one LED. You can unmute them. Whoever they want, they can speak. So the host, you can unmute them. If anybody wants to speak, they can speak. Are you there? Host, are you there? Okay, I have unmuted. If you want to tell something, you can tell. Okay, am I audible to everyone, right?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So project number 1 is interface with output device. You will do what? LED on. So what is your requirement? So basically first you try to understand your requirement. Okay, so this is my controller. First thing you will do the design. Now tell me where you will connect. Where you will connect the LED. You can connect anywhere. Wherever you want, you can connect. Okay, whichever pin. You can connect in P1, you can connect in P2, you can connect in P3. Wherever you want, you can connect and you can do it. As of now, I'm connecting in P2 register. Okay, so how many? So if you'll see P2 having 8 pins, if you'll see P0 having 8 pins, if you'll see P1 having 8 pins, if you'll see P3 having 8 pins, right? Where I'm connecting in P2 zeroth number pin. So P2 register is there. You can see P2 register is there. You can see I'm connecting in P2 0 number pin and I want to make the LED on. Okay, I want to make the LED on. Before going to this, how you have to tell to compiler what all things you are using. Okay, so we are going to use 2 keywords. One is SFR, one more is SBIT. There are 2 registers are there, or you can say 2 keywords are there. One is SFR, one more is SBIT. SFR means special function registers. The full form is, so SFR means why SFR you are using. Why SFR you are using. So now suppose you are going to use P2. Now can you tell me this P2 register where it is present in the controller? It should present in some memory address, right? It should present in some memory location. If I'll ask, you are from which locations? You are telling, sir, I'm from Maharashtra. I'm from Mumbai and my house is in this place. If I'll ask, you have to tell the answer, right? Same way, if now we are using P2, where P2 is present? Where P2 is present, where this P2 register is present, that you have to define. For by using SFR register, by using SFR register, by using SFR, you can define. So how you will use? SFR is mainly used to map all the register, all the port, or you can say all the registers. So that is the use case of SFR. SFR mainly you are using to map the registers. Now tell how you will do it then. So you can write SFR P2. SFR P2 equal to 0x80. Some address I am randomly assigning. It's a 8-bit registers. In 8-bit registers, that 8-bit I'm representing in hexadecimal format. What is hexadecimal format? What is binary format? If I'll tell all these things, it will not finish the class. Okay. So I'm representing in hexadecimals. Same way, suppose you want to use P3 register. Suppose you want to P3 register, what you will write? Same way you can write SFR P3 equal to some address. You can 0x90, you can assign. Clear? That is the use case of SFR. Then why you are using S-bit? Then why you are using S-bit? Then why you are using S-bit? S-bit mainly it is used to map each bit, or you can say pin in a register. Now tell me, how many pins are there or how many bits are there in P2 registers? How many?
8 bits.
8 bits. In P08, P18, P28, P38. So every bit. Suppose you want to access 0 number bit. Then what you will do? You will use S bit. So what you will do? You will use S bit. S bit P2 caps operate. Sorry, P2 0 bit. S bit P2 underscore 0 equal to how you will access P2 caps operator 0th bit. That means if you are using, you have to tell to the controller. If you are using, you have to tell to the controller in this way. You have to use in this way. You have to use SFR. In this way, you have to use S bit. Now, suppose one more time. Suppose I want to use one more bit. P3 register 2 number bit. P3 register 2 number bit I want to use. Then how you will represent? S bit P3 underscore 2 equal to P3 register caps operator 2 number bit. You can write in this. Understood everybody? Yes guys? Yes?
Yes.
So now
Yes.
you have to write the program. So now you have to write the program. However you have done, same way you have to write the program. Before writing the program, I want to tell one more thing. Basically, in the digital world, we are playing with 0 and 1. In the digital world, you are playing with 0 or 1. So if I'm telling 0, see this controller, we can give maximum volt 5 volt. For this controller, we can give maximum 5 volt. So we can deal with 0 or 1. 0 means you are giving 0 volt. That means also you can say ground, or you want to off anything, you can say off. Same way, 1 means you are giving 5 volt, or that also you can say VCC. Or if you want to on any device, you have to give 1. If you will give 1, that 5 volt will apply to the LED, then LED will on. Simple. If you want to give 1, that means here it will pass 1 volt, sorry 5 volt, and the LED will on. Clear everybody up to this? Yes.
Yes, sir.
Okay, now we'll start doing the program. So what we'll do, I'm creating one folder here. Okay, I'm just creating my first project. Project number 1, suppose I'm telling LED on. Okay, and now my software is already installed. You can search for Keil Microvision 5, open it. So you will open the software. Whenever you will open it, you go to project.
Sir, can you please tell how to download that software?
I already told. Yesterday also I told. From today also, from starting I told. In front of you, everyone, I also downloaded. I also installed. Okay. Already link
Can
is
you
there.
please tell again?
Already link is there. Keel software, Keel Microvision software. From there you can download it. If you go to keel.com, if you go to download, go to product download, click on this, then you can download here. Okay. So now, guys, who are not talking anything, please mute yourself. Who are not talking anything, please mute yourself. Okay, now go to project, then create a new microvision project. You have to create a new microvision project. Then where you'll save it, you can save. So generally how they're writing code in the industry, I'm not following that standard now, because in 1 hour I cannot finish if I'll follow all these things, but I'll tell you how to start it. Okay, generally whenever you're writing the program in industry, you have to follow some folder structure. I'm not doing that one now. I'm just creating my project, LED on, save it. When we'll save it, it will ask for the controller. Which controller you're using? We are using 8089C51. This is our controller, 8089C51. You click on this, then okay. Then it is telling copy startup code. Yes, you have to copy the startup code. Basically, startup code is very necessary. It will what is startup code? If I'll say startup code is the code which will start your controller. Whenever you are booting, whenever you are making on your controller, what all memory segments are there, it will initialize. All these things process will start. For that reason, you have to make it yes. So you can see here project LED on, you can got here. Okay. So now this is done. Then what you will do, go to file, create a new file, then save it in the same folder, whatever folder you have created, same folder, save it, main.c, save as main.c. Gupta, Mardul Gupta, you please mute yourself first, otherwise I'll make you mute. Okay, so in the same folder name, you have to save as main.c. Done. So you can save as main.c. Then you can write the program. Before writing the program, you have to do some steps. Okay, this is the things. This is the setting option for target. You have to click on this. Okay, what this controller using the frequency 11.0592 megahertz, that you have to set. And whatever program you are writing, that you are writing in the laptop, but that where you load the program, you will load the program in ROM. That program you are going to load on the ROM. So use OnChip ROM. You have to click this ones. Then output, because whatever program you are going to write as .c, that microcontroller will not understand. Microcontroller only understand machine language, and that machine language, right? That code, it will convert into binary or hex file. So basically there are some binary format is there or .hex format is there. So we are going to create here .hex file, and that we are going to put in microcontroller. This project you cannot put all the executable code or the buildable code. After executing that code, you are going to put in the controller. Otherwise, your microcontroller will not understand. So you are going to create hex file, and where you will save it? You will save in the same folder. It will save as .hex format that you are telling. Create hex file, that you will do it here. Then user C51, you have to set the label as 0. That means you are not doing any code optimizations. So very basic things. And if you are using any driver or if you are writing any driver, where you are saving it, that path you have to give. As of now, I am giving the same path. Okay, done. This is the setting done. Now setting is done. Now we have to write the program. For 8051, we have to write the program. We have to use some header file. One header file has include. Why I'll use the header file, that also I'll tell you. Register 51.h. This is the first line you are going to write. Register 51.h. Now tell me, what is your requirement? What is your requirement? Your requirement is you are going to make LED on. LED, where it is connected? Where it is connected? It is connected in port to 0 number pin. Am I correct? Yes, are you there? Okay, I'm going to connect in port to 0 number pin. I'm going to connect in port to 0 number pin. If I'm going to connect in port to 0 number pin, that what you will do? We have to define port 2 and 0 number pin. We have to define port 2 and 0 number pin. We have to define port 2 and 0 number pin. So how we will define port 2? By using SFR. SFR port 2 0x80. Suppose you are giving. So how you will define that pin, that bit, S bit, port 2 caps operator 0, sorry, port 2 underscore 0, then port 2 that caps operator, then 0. Port to 0 number pin I'm using. So now then you will write void main. How you are writing the C program? I told, if you are good in C program, it's very easy to understand. Otherwise, you have to learn and you have to do it. Okay. So void main. Now you can write the program. How you will make LED on? How you will make LED on? What I told, one more thing I told, if I'm telling 1, that means LED is on. If I'm telling 0, that means LED is off. What is meaning the 1? 1 means I'm giving 5 volt. Okay. So what I'll write inside void main, if where LED is connected, LED is connected in P2 underscore 0. So P2 underscore 0 equal to 1. If I'm telling, then LED is on. Then LED is on. Simple. Instead of P2 underscore 0, also directly you can write LED. Then where LED is connected? LED is connected in P2 underscore 0. Where LED is connected? LED is connected in P2 underscore 0. LED is connected in P2 underscore 0. Okay. P2 underscore 0 equal to 1, where LED is connected. Okay. Now, what will do? P2 underscore 0 equal to 1, where LED is LED on. Okay. So how many times this program will run, guys? Are you able to unmute?
One time, sir.
One time.
One time.
Exactly. This program will
One
run
time,
for
sir.
only one time. This program will run only for one time. So this program only run for one time. So how this program will run for infinity times? How this program will run for infinity times? Anyone?
So while loop.
Exactly. If we'll put while loop here, it will run for infinity times. It will run for infinity. Sorry, somebody is telling something. So it will run for infinity times. Whatever you are going to put inside the while 1, it will run for infinity times. So now this program will run for infinity times. Understood, everybody? Clear?
Yes, sir.
This is the program. So this is the program. Okay. So this is the program. Now, what are the steps again? Now you have saved it. Now this program you have written. So whatever .c file you are going to write, you have to add here in the source group 1. Otherwise, it will not go for compilations. So right click here, add existing files to source group 1. Then there you have to click on main.c, add it. So you will get here. So now I will compile it. So now I'll disable it. Why I'll disable? I'll tell you. Okay. I'm not using this line now. I'm disabling it. So now save it. So this is the button where you will do the compilations. So it's telling 1 errors. Okay. What is P2 underscore 0? Now you have changed to LED. So that also you change your LED. Now save it. 0 errors, 0 warnings. This is the compilation. If we'll do this one, it will build the project and it will generate the .hex file. If you'll see the folder here, you can see there is no .hex file. C file is there, A51 file is there. There is no .hex file. Once you will click on this ones, it is telling what? 0 errors and 0 endings. It's telling creating the hex file LED on and the size is 9. So this we are creating the hex file, and where we are saving? You are saving here. You can see now LED on hex is created. Okay, so this project is done. So now how you will verify either your LED is on or not? How you will verify either your LED is on or not? For that reason, we have installed one more software that is called Proteus. So that also will open now. Click on new project. It will take a little bit time. You can save wherever you want. So as of now, I'm saving in the same folder. First time it will ask all these things. Okay. Okay. So first time, because I have installed in front of you, it is asking. Okay. So now here, there are two things. One is P and one more is L. If we click on P, right, what device you want? What device you want? So I'll search 889C51. So that device I'm searching here, 889C51, make it okay. So here you can see this device came. Here you can see this device came. If you want to make it large, here you can see it is coming. Okay. And here you can adjust where you want to keep. So you are keeping here. And one more device you want, what is that? LED. You want LED. You want LED, you can search LED. There are so many LED will be there. Okay, LED, blue, green. So LED green I'm taking. So this is the LED green here come. Here you click. Again here you click. So you can rotate the direction also. Which direction you want, you can rotate. So this is the positive side and this is the negative side. It is connected with P20. So just click, drag and drop. That's it. Connected. Then you want one more ground. For ground, you have to see here. There is some modes are there here. You can see here. So you have to go here. This is one button you can see. Terminal modes. You can click on terminal modes. Then you can click on ground. Then you click here. Then finally you can connect here. Now it is connected. If you want to go again, this component mode, you click here. If this is your component mode, this is your terminal mode. Mostly you will switch. From terminal mode, you will take ground, VCC, all these things. This is component mode where you will take the component. This is the project is done. So now you have written the code in the computer. This code is there in computer. Still till now this code is not present. This code is there in computer. Till now this code is not present in the controller. This is your controller. So now we are creating virtually, but generally you will work in real hardware. Whenever you work in real hardware, that is the controller. You have to jump that code from computer to controller. Basically that term is called flashing. That term is called flashing. So basically you will flash the code in the controller. Then how you will do it? Double click on this. Then here you have to load the program files. Program files only it will take the hex. LED on, only it will take the .hex format. If you will open it, okay, then you play the button. Your LED is on? Yes?
Yes, sir.
So this is one project, okay? We'll do one more project now so that you will get one more clearance. Okay. Why I have not written
What is the role of SRF P2?
Sorry?
What is the role of SRF P2? You committed.
SFR P2. Okay. Why I have not done it? Okay. Because whenever this compiler is there, right? This compiler is doing itself. I'll show you that one. So now we are using one header file, right? Register 51.h. If you click on main.c, you can see the register 51.h header file. All these things already here defined. For that reason, I did not define one more time. Clear?
Okay, got it, sir.
For that reason, they have whatever registers are present in 8051, whatever registers are present in 889C51 controller, all the registers they have already assigned. Basically, who all are manufacturer of the controller, right? Who all are manufacturing the controller, generally they will assign the address. So they already assigned, and that I'm only using. For that reason, I have skipped this one. Clear?
Yes, sir.
So now we'll do one more project. What is the project? Now we'll do project number 2, where we'll interface with input device and output device. Now, what is my new project? The project number 2 is interface with input device. So basically you will use one switch. Okay, same. So now again we have to use this controller. Okay, this is the controller 8089C51. So the controller name is 8089C51, and we have to use one switch. This is the switch symbol. This is my switch symbol basically. And where switch is connected? Switch is connected, suppose P1 underscore 5 number pin, and we have connected one LED. We have connected one LED. And wherever you want, you can connect. You can connect in P2. Same, you can connect in the same pin, P2 CAMPS operator 0. There. What is my requirement? If I'll press the switch, then LED on. Clear? Suppose you are entering to shopping mall. Whenever you are entering to shopping mall, that time door is open. Same kind of concept. Okay. Now you have to write the program. So basically, your switch will always work in opposite logic. Your switch is already connected with the pin. Whenever it will connect with ground, that time your switch is on. Always you have to check that. If it is connected with ground, then switch is on. That is the logic. Okay. Now I'll create one more project. I'll do for again a new one so that it will be easy for you to do. So I'll create one more project number 2, LED switch. Okay. So what you will do, again go to project, new microfusion project, go to second project and give switch underscore LED. Save. What will search? 8089C51. Okay. Copy the startup code. What I told. Again, you have to file, new file, save as main.c in the second project.
So always write a main.c or any other name.
You can write whatever you write. You have to give the link here. That's it.
Oh,
Okay. You can write your name.c also. Yeah. You can try. So main.c, then you add here. I already told whatever. So tomorrow you are going to do so many projects. That time you have to add lcd.c. You have to write all the drivers. You will write. So that is required. So add existing project. Main.c you have to add. So you can write the program. Okay. Hash include. So how many ports you are using? How many pins you are using?
2
pins. Register 51.h. As you know, I'm not using SFR directly. I'm using S-bit. Where switch is connected? Switch is connected in P1 CAPS operator 5 number pin. And where LED is connected? S-bit. LED is connected in P2 CAPS operator 0. First you have to tell what you are using. Okay. Then void main. Then inside while one, you already knew because it should run for continuously. So how you will get to know that the switch is pressed? Always you have to check some condition. If whatever switch equal to 0, right? So what I told, Whenever it will connect with ground, that time switch is on. So when it will connect with ground, when switch is pressed means that time your switch equal to 0. That means your switch will become 0. When switch equal to 0, that time give LED equal to 1. That means LED on, else LED off. Simple, very simple programming. Once you'll understand, right, you'll enjoy it. So only you have to understand the things. You have to only understand the things, then only everything is easy. For that reason, I told first you learn C language, then you have to go here. LED off. Okay. So now the program is done. Now we have to do the setting. I think the setting I have not done here. 11.0592. Use on CPROM. Target, create hex file, and you have to store in the folder, whatever folder you have created. Here it is 0. And whatever path you are setting, any path you can give, wherever you have kept your things. So this is not necessary that you have to give only this path. Done. Then I am compiling the code, 0 error, 0 warnings. Your hex file is created, right? Your hex file is created. Done. Now I'll check the same thing in Proteus. I am using the same project, only I'll add one more switch here because there is no time to switch there. Okay, so this is my switch. It is connected where? P2, 5, right? Leave it. So now I'll take one ground. Okay, so done. Then save it. Double click and take the code from there. It is there in the second folder, LED switch, and take the hex file. Open. Okay. Now I'll on it. Is your switch on? No. If I'll press the switch, now your switch should on. Why it is not on? P15, still it is not on. Then what is the problem? We can check our code. P2, 0, if switch equal to 0, LED equal to 1, otherwise LED equal to 0. P2, 0, P15. Yes.
Sir, I think you
Sir, first configure to input the thing for
That is
input.
That is already configured, right? What you will configure again? Not required. 1 minute.
So the switch one is connected to P15, sir.
I used to connect it
Yes,
before.
yes. That is the wrong thing I have done. Thank you. Thank you for identifying the problem. Now it's connected to P15. Now you can run the project. Sorry?
No, sir. Wrong connection.
Oh, again wrong connections. Again wrong connections. Okay. Now correct?
No, sir. Again, wrong connection.
P15, right?
Yes, sir. 5.
P15 connected?
Yes, sir.
Yes, sir.
Now we'll run the program. Now LED is off. I'll press it now. LED on.
Yes, sir.
Now again LED off. LED on. LED off. LED on. LED off. Now yesterday I shown one project, right? Did you remember? Yesterday I shown
Yes,
one
sir.
project where I have connected LEDs. Yes, where I have connected LED doors, then motor, then your switch, everything. So slowly you learn. So I'm not telling that everything you learn in the first day. I'm not telling that everything you learn in first day. So this learning process, right? I am just giving you the basic thing. So tomorrow instead of LED, you will connect one motor here. Next day, instead of motor, you will connect one stepper motor here. Next day, instead of stepper motor, you will connect one LCD here. Next day, instead of this, you will connect one sensor. Next day, instead of this, you will connect one keyboard. So slowly, it will connect one by one, and finally you will do the projects. And very important things, why I'm telling all these things. So once you, whatever small project you are doing, this is very small one, right? This is very small one. I knew this is very small one, but if you are doing yourself everything in your own, this small kind of projects, it will give you the enough confidence. It will give you the enough confidence to go for any interview and tell the answer, what you have done. If you are presenting the same thing in a neat and clean way, right, it is enough to get a job. So for that reason, I am telling, don't go for higher end controller. So whatever small controllers, you will take it and start doing the project one by one. So that is the main important thing. So I just gave the glimpse. So how to start the program and which all softwares you are going to use, and what all softwares you are going to use, how to start the program. Then the next thing is what all, how to start the coding, how to configure the controller, how to configure the pins. Then now you can do one by one. You can connect one by one device, and I think then after then you can do whatever things you want, right? Whatever things you want, so you can do it. So I think this is a very simple steps. I just wanted to show you in one. I think in 1 hour I cannot go for much. You know, it's difficult things, right? So yeah, so this is about the project. So now what is the next step? Next step is, right, so next step is you start doing this kind of small project and try to learn so many things,